Welcome to Skull Cracker. In this session, the topic I'm going to deal are viscosity, drag force, and terminal velocity. Let's start. To understand viscosity, let's consider a piece of pipe in which some liquid is flowing. Consider this to be the edges of the pipe, which are fixed. These are the laminar flow of the liquid. As we know, liquid or any matter contain molecules. When this layer of the liquid is flowing, the molecule of this layer comes in contact with the molecules of the layer below it, or for that matter, above it. When this layer flows forward with certain velocity v, it tries to drag the layer below it along with it in this direction. But due to the molecules coming in contact with each other, there exists a friction between them. There exists a friction between them, and this process keeps on moving to the edges. The molecule of this layer comes in contact with the molecules of this layer. The molecule of this layer come in contact with the molecule of this layer, and the molecule of this layer comes in contact with the molecule of this layer. What is the work of this friction then? The work of this friction is to retard the movement of the layer of the water. That means this layer will try to stop the or retard the motion of the flowing layer. This layer will try to retard the motion of this layer. This layer will try to retard the motion of this layer, and ultimately the edges will try to stop the motion of the layer that is flowing just above it, that is this. So then what is viscosity? We can simply define viscosity as when a fluid flows in a pipe, a retarding force occurs starting from the upper layer to the lower layer. The property of the liquid by virtue of which it opposes the relative motion of its layer is known as viscosity. So let us write. Now we have understood what is viscosity. So viscosity is nothing but it's just a property of the liquid that opposes its own layer, the flowing layer, by another layer. Up next, the topic is drag force. Here as well, to understand drag force, we will consider a piece of pipe in which some liquid is flowing. Due to the property of viscosity, the layer just below opposes the movement of the layer above it. In this case, this layer, the molecules of this layer oppose movement of this layer. Similarly, the molecules of this layer opposes the molecular movement of this layer. Likewise, it keeps on. So in short, there exists some force between the two layers. For instance, the force exists between the fixed layer and the layer just above it. Similarly, there is a viscous force between this layer and the layer just above it. Supposing this is Fp1, this is Fp2. Then how can we define viscous force? Viscous force is that force applied due to the friction between the moving layers of the liquid that opposes the movement of the first layer of the liquid by the second layer. Thus, viscous force can be defined as it's the force that exists due to the friction between the molecules of two movable layers, or a movable layer and a fixed edge that opposes the flow of moving layer of the liquid. So now this viscous force, this viscous force work is to resist the movement of the flow of the liquid. Consider viscous force F. F is viscous force. AB, area of the surface in contact. V, the velocity of moving layer, and L be the distance of moving layer. Then this viscous force can be mathematically written as it is directly proportional to area of contact, and it is directly proportional to the velocity of the moving layer, and it inversely proportional to the length distance of the moving layer from the fixed edge. So when we combine this, we can simply write viscous force is directly proportional to area into velocity by L, or proportionality constant eta, just write F equals to N A B by L. So the force of viscous formula is given by F is equal to eta A B by L, and this proportionality constant is nothing but it's the coefficient of viscosity. The unit of force is always Newton, SI. But then what is the unit of the coefficient of viscosity? Coefficient of viscosity is given by this relation. The units of force, area, velocity, length are given here. Now when we put this units here and cancel out or the similar terms, it is found out that it is Newton meter square into second. So this is the SI unit of the coefficient of viscosity. Now this can be written also as Newton force per unit area is Pascal second, or simply Pascal second is named as Poiseuille or simply Poise. Therefore, the SI unit of the coefficient of viscosity is the Poise. Next topic is terminal velocity. To understand terminal velocity, a simple experiment is referred. Taking a beaker filled with some liquid, a solid object, say a marble, is dropped from some height into the beaker. The marble falls freely due to acceleration due to gravity and reaches the liquid surface, and ultimately it enters the liquid. The force by which it falls into the liquid is due to the weight of the marble, that is mg force, which will be acting downward. When the marble is falling freely, at this time two forces will be acting upon the falling object. These forces are directed upward, and these forces are none other than force of buoyancy and the viscous force. At one point, when the force of buoyancy plus the force of viscous equals the force due to weight of the marble, acceleration of the body reduces to zero. What does this mean then? Will the body stop falling down now? No. The answer is no. This means the velocity of the body, the rate of falling of the body, that is velocity of the falling body, will be constant now. After this point, the body will fall with a constant speed and reaches the base of the tube. And this constant velocity with which the body falls is termed as terminal velocity. Let us define terminal velocity then. Terminal velocity is the maximum velocity an object obtain, or achieve while falling through a liquid. Now we can just write what is terminal velocity. Like other velocity, its unit is also meter per second. I hope this lecture will help you all